Okay, so we had kind of left off in the middle. We were talking about acid and base regulation and regulating the pH in the body through the respiratory, renal, and buffer system. We've already gone over the buffer system and the respiratory system, but just to recap, our pH for our body is 7.35 to 7.45. Again, think of middle age being 35 to 45 in your lifespan. That's how we can remember that. The buffer system is your phosphate, your protein, and your bicarb, which basically takes strong acids and turn them into weak acids. That creates byproducts, which amount to sodium chloride, water, and CO2, or salt and CO2. So that is the buffer system. The buffer system works very quickly, but cannot work for that long. Your respiratory system was a little bit more complicated. Your respiratory system was responsible for regulating your pH in your body by taking the metabolic products or the waste products of the metabolism, which is CO2 and water. It takes that CO2, they are attached to the red blood cells, and in the red blood cells they combine with water, making this horribly huge thing for the red blood cell to carry around. Thus, the red blood cell breaks it down into hydrogen, which is carried to the lungs for excretion. So, why does this matter at all? Basically, it means that that CO2, through several different processes, equates to free hydrogen in your body. So, the more CO2 you have built up in your body, the higher your hydrogen ion. The less CO2, the lower your hydrogen. And again, hydrogen is what's going to determine your pH level. pH goes from 0 to 14, 0 being most acidic, 14 being most alkaline, and it's the measurement of hydrogen ions in your body. So that's how pH is determined. So that's how the respiratory system works. It basically gets rid of hydrogen in a series of steps by excreting it out of the body. So from that point, we had left off at the renal system. The renal system is pretty simple. The renal system helps control pH by getting rid of free hydrogen. It's going to just excrete it. So the renal system has the ability to either excrete that hydrogen or keep it. Either way, it's going to try and excrete or keep your hydrogen to regulate your pH. All right, urine pH is normally 6, but it has the ability to go down to 4 and up to as high as 8. So it pretty much determines what acidity the urine is by the amount of pH in your body. Now, naturally, if you have an issue with your renal system, then you're going to probably have an issue with your pH. So that's the gist of acid-base regulation and the things that our body uses to help regulate that pH in the body. So let's move forward. We are going to move into respiratory acidosis, and I'm going to just start with respiratory acidosis and alkalosis, and we will hit the metabolic acidosis and alkalosis in another video. Respiratory acidosis. Remember how I said the higher the CO2, the higher the hydrogen ions in your body. So the more buildup of CO2 that you have in your body, the more, sorry, there's a glare on that, the more CO2 in your body, the more hydrogen, thus you are acidic, or acidosis in this case. So, as you might suspect, on the other side of the spectrum is alkalosis with a low CO2, and that creates a low pH. So what causes CO2 to build up in your body, or for that matter, a low CO2? We need to look at the ways that it manifests itself. So the acidosis manifests itself through the buildup of CO2. So how do we build up CO2? Well, if your body's not getting rid of CO2, it means that something's going wrong with your pulmonary system. It could be COPD, maybe barbiturate overdose, sedative overdose, respiratory muscle weakness. So there's several factors, but basically, if your body is not able to blow that CO2 off, you will end up with an acidic environment. So anything that lowers your respiration rate, you're going to find that it happens anytime there is a blockage or anytime that the pulmonary system is not able to excrete that CO2. So low respiration rates, buildup of CO2, thus become acidic. All right, alkalosis. So that's when we have no CO2. So just like the acidosis, the opposite side is for hyperventilation. So if you are blowing off just tons of CO2, then you are going to end up with a pH that is below normal. The causes of this might be anxiety, fear, exercise. Let's see what else. Brain injury has a big part in this because it senses CO2, so that can also affect it. But hyperventilation, so anything where you're blowing off tons of CO2. And the way that I'm looking at this right now is basically like your college frat, your college frat party. So acidosis. All right. So when do you have a buildup of CO2? Well, when your respiration rate is lower than it should be. Often is the case with alcohol use, barbiturate overdose, alcohol poisoning, things like that. That lowers your respiration rate. Right? Low respiration rate. This college frat boy, he's drowsy, he's confused, he's dizzy, and he has a headache. Now, it might seem that the symptoms from your acidosis and alkalosis are very similar, but if you think about it, you can see that that's not the case at all. This is your college frat boy who is barely awake, confused, dizzy, headache, low respiration rate, drank all night, barbiturates, all that jazz. Alkalosis, on the other hand, is a person who you can't stop moving. This person doesn't want to get up. This person can't stand still. This person is hyperventilating. They are stressed out, have high anxiety. I would just like to look at this as finals in nursing school, okay? So, here comes finals and you're hyperventilating, you're lightheaded because you're hyperventilating. You might get dizzy, a headache, and and confused. So this is how you would feel in finals. This is how you would feel after a night of heavy partying. There's a big difference here. So that's how I'm going to remember those. And we will go over metabolic acidosis and alkalosis in another video.